We're going to look at an alternative CMOS full adder. But to start off with, we'll recap on the NMOS full adder, which we've seen in a previous video. So this is the NMOS full adder here, and we had the carry section here, but remember this is a not carry, and we had the sum section here as well, and this is the sum here. So if you can't remember this, have a look back at the NMOS full adder. Now what we want to do is we want to take this circuit here and change it into a CMOS full adder, and we're going to do that by changing the series combinations here and the parallel combinations to parallel and series combinations of the PMOS device. So we're going to have the pull down section here, which will remain the same, but we're going to add on to a pull up section, which will be the CMOS section. So let's go ahead and we'll have a look at that in the next page. So this is the alternative CMOS full adder. So let's take this and we'll compare it to what we had above. So this is what we have above here. We've got our 1, 2, 3, 4, 5 transistors. Now this little section here is ostensibly just the same. All I've done is I've taken the C and I've put it above the A and the B, but it's still in series. So you can see this here. We've got the C and it's just sitting above the A and the B. So there's no change there other than aesthetics. And we've got the A and the B here, which are in series, which is just this A and B here. So this little section is just the same. And then we're going to have the carry, or rather the not carry here, feeding into this transistor. And again, we've got the not carry coming along and it's feeding into this transistor here. So that's still the same. And we're going to have the 3 in series, and we're going to have, 3 in parallel and the 3 in series here. And that's what we have above. We've got the 3 in parallel and the 3 in series. I've just put the parallel ones down below this one as opposed to up above it, but it doesn't matter as long as this one is in series with all of these 3. And that's what we've got here. We've got this one is in series with all of these 3, and we've got the 3 here that are in these 3 here that are in series. So we can see that the bottom half of this, if you take your time and look at it, the bottom half of this here is exactly the same as the bottom half of the NMOS, which is hardly surprising. We know that whenever we create our CMOS circuits, the pull down logic is going to remain the same. But we don't need these 2 transistors here. These are our enhancement loads for our NMOS, so we're not going to be using those. We're going to be using a separate PMOS pull-up network. So in order to get the pull-up network, we have to take what we've got down below here, and we have to change the series resistors into parallel resistors at the top, and parallel resistors into the series transistors at the top. So our series and parallels just get flipped over, and you can see that's what we've done here. So let's just follow that. We're going to have these 2 transistors A and B, which at the moment they're in parallel. So whenever we go to the top section, the pull-up section, they must be in series. So these 2 are these 2 here, which are now in series. So they were in parallel here, they're now series here. Now the C here as well, it was in series with these 2. So now it'll have to be in parallel with these 2. So we just leave it as it is there, and it's now in parallel with these 2. Now finally, these 2 here are in series, so they must be in parallel. So this is those 2 here now in parallel. So we've changed all the series combinations into parallels, all the parallel combinations into series, but ostensibly we've just ended up with a carbon copy of this above here. except we've got it with PMOS devices for the pull-up. Now this point here comes along in the top one, and this is the carry, not carry output here, and it feeds into this transistor here. So this transistor here is just this transistor here, so that's still the same. But we'll also have to have it feeding into the same transistor for the PMOS, for the pull-up. So we've got the alternative transistor sitting here. So this is the PMOS device sitting here. So this is the feed into this network. Now we can see here that we're going to have 3 transistors in parallel down the bottom here. So these 3 transistors will have to be in series in the top and the pull-up network. So these 3 here are now in series up here. And we've got the series combination here will have to be in parallel, and that's them in parallel here. So again, we've got a carbon copy of the bottom up and the top by switching parallel and series combinations. So that's ostensibly everything that we need. What we can do now is we know that we're going to have the NOT carry here. So in order to get access to the carry, we can put it through an inverter. So that's our inverter, which will give us our carry. Again, we're going to have the NOT sum coming out here. So in order to get access to the actual sum, we can put it through an inverter and we get the sum. So this is our full adder in CMOS. And this is the one we're going to actually implement in the EDA electric tool. So we've got our A and our B input. We've got our C, which is actually our carry in from a previous summation. We've got our carry out, and we've got our sum. So that's all for this video. Thank you for listening. I'll get you on the next video. Goodbye.